Number 15 is asking us to find all critical points of this function here. G of theta is equal to sine squared of theta. So critical points happen anywhere that your derivative is 0 or undefined. So let's see what we can come up with for our derivative here. G prime of theta equals, and remember guys, sine squared of theta is actually the sine of theta, in parentheses, quantity squared. So we're going to use the power rule on that. We're going to bring the 2 out in front. We're going to keep the base the same, that's sine of theta. Technically, that gets taken to the first power, but we don't need to write that. And then chain rule times the derivative within. And the derivative of sine of theta is cosine of theta. And that's our derivative there, guys. All right, nothing can be done to simplify that at all. Let me go a little out of order. The second way you can get a critical point is if your derivative is undefined. Well, what I'm hoping everybody remembers, our friends in pre-calc are working on this right now, sine of theta and cosine of theta are the two trig graphs that never have any vertical asymptotes. That is because those two functions are defined for all real numbers of theta. They're always defined. There's nowhere that it's undefined. And multiplying two defined numbers will always get you another defined number. So there is nowhere that this derivative is undefined. However, there are certainly spots where this derivative is equal to 0. And how do we handle that? Our friends in Algebra 2 right now are working on having factored expressions right here. Theirs are polynomials, but that's okay. Factored expressions set equal to 0. And once you get it factored, like we have it right now, you take each of those factors, set them equal to 0, and solve. And there are certainly solutions to this equation. Now, as I look at number 15, there were no restrictions in this problem about what values of theta we were looking at. So when I ask you guys what values of theta have a sine value equal to 0, there's a whole bunch of answers to that question. In fact, there's an infinite number. So if we were to go to our unit circle here real quick, I would hope you guys remember that our sine value is y, or your y coordinate at any point on the unit circle. So I'm just asking you guys right here, where on the unit circle is y equal to 0? Y is equal to 0 on the x-axis, right here at 0, right here at pi, and then keep going, 2 pi again, 3 pi, 4 pi, 5 pi, and so on and so forth. So what we would say right here is this happens anywhere that theta is equal to pi multiplied by n, where n is any integer. Okay, so anytime that happens, theta is equal to pi n, we have a spot where our derivative would be 0, and that's a critical point. And how about over here, guys? Where is cosine of theta equal to 0? Well, cosine, let me switch colors on you right here. We'll go green with this one. Cosine is our x value. Where on the unit circle is your x value 0? On the y-axis. Right here at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9. Okay, you get it. So what happens right there? That's what happens when theta is equal to, all right, your first one right there was pi over 2. So I'll start with that. And then you add to that integer multiples of pi. Pi over 2 plus 1 pi gets you to 3 pi over 2. Adding 2 pi to that gets you back there. So what we're doing then is we're adding pi times n to that one right there, where again, the understanding that n is any integer. Okay, and so putting that together then, guys, I would say that these are your answers to this question. Now, what's really happening, though, and I bet the book kind of went a step further right there just because they wanted to show off how smart they were. What's going on then, guys, is that really this ended up being a critical point, that angle, and this one, and this one, and this one, and this guy, and this guy, and this guy. Basically, it's every pi over 2 units. So I would absolutely not expect you guys to do this and not require it, but you could put all that together and say that theta is equal to, what are we jumping by there? Pi over 2 multiplied by n. All right, if n is 0, that gets you this angle. If n is 1, that's right here. If n is 2, right there. If n is 3, right there. If n is 4, we're back here. 5, 6, and so on and so forth. So that answer right there is probably the more succinct way to do it. And as I'm looking at the solutions manual, yeah, they've got theta equals n pi over 2, which is exactly what we have. So that's the best way to do it, but I would think you guys would probably go right here and say, you know what? That's good enough, and I'd give you full credit, of course, for that answer.